Good day, good day, good day. Welcome to our page. My name is Stiffler, and before us today we are having trigonometry 2D. This is grade 10 work. So this grade 10 work is not that much difficult. It just emphasizes on what we dealt with already when we're dealing with the trig ratios. So let's just remind each other of all the trig ratios that we know. Just like if we're having a triangle here, not just any triangle but a right angled triangle. So what do we know every time we are having a right angled triangle and we are having sort of an angle theta there? We always know that the sine of theta is equivalent to the opposite over the hypotenuse, right? And we also know that the tan of theta, so the tan of theta is equivalent to the opposite over the adjacent, right? So this is the adjacent, this line that is closest to the angle, and this other line, the longest line, is the hypotenuse. And we also know that the cos of theta is equivalent to the adjacent over the hypotenuse. So in grade 10 2D we deal with only these three ratios. These are the three ratios that we focus on. We don't focus on the sec and the cosec. So we focus on these three, right? So it is important to always remember this when we are dealing with these 2D shapes. So in this 2D trig, what you almost deal with is when you are having maybe two triangles. Maybe you can have two triangles and both they'll be right angled triangles, something like this, and this is 90 degrees and that is 90 degrees. Maybe you can be given the angle there and you can be given a line there, right? So maybe you are given the length of this line from this point to this point, and also you are given this angle, and you are required to find something in this triangle. So it can be hard, but if we can see what is connecting these two triangles, it becomes simple, right? Because what is connecting these two triangles, it is this line there. So once we find the length of this line, it means that we are bringing the information to this triangle, and we can use that information to find that, something like that. So that's what we are going to deal with when we are dealing with these trig 2D shapes. Don't worry about it now. We are going to do more examples so that you can get what is going on here, right? So what else do you have to know? We also have to know these two definitions. They will help you to master whatsoever that you need to understand. So what is these two definitions? It is the angle of inclination. So the angle of inclination, it is the angle between the horizontal and the line connecting two objects when you are viewing from below. I'm going to show you a diagram that is going to help you to understand what is the angle of inclination and what is the angle of depression. And you also have what you call the angle of depression. So now, what is the angle of depression? This is the angle between the horizontal and the line connecting two objects when you are viewing from above, right? So let's take a look at this diagram. So here we're having two objects. We're having object A there and we're having object B there. And this blue line is showing the horizontal. So a horizontal is a straight line that is parallel to the ground, right? So we're having two horizontals. We're having either horizontal where the object is seen from above, and we're having another horizontal when the object is seen from below. So these are the two situations that we're having. So now, what is the angle of inclination and what is the angle of depression? So if you can see here from the object that is below, since we said the angle of inclination is when you are viewing from the object that is below. So here, this is our horizontal, and this is the line connecting the two objects, object A and object B. So this angle that is lying between the line connecting the angle, the object, and the horizontal line lies our angle of inclination. So this is the angle of inclination. Angle of inclination. And also when you are viewing from the object that is above, we can see that we are having our horizontal as well. So this is our horizontal, and this is the line connecting two objects. So this angle that lies between those, we call it the angle of depression. So this is our angle of depression. So it depends on the perspective really. So if you are viewing from the object that is above, we have the angle of depression. If you are viewing from the object that is below, this is the angle of inclination. But however, if you can check here, in terms of Euclidean geometry, we can see that we're having parallel lines and we're having a transverse line. Can you notice that this angle must be equivalent to this angle on alternative angles? So which means that if you're having two objects that are locked in and you're having a line connecting them, it means that our angle of inclination must be equivalent to our angle of depression. So whenever the situation that you're having, if you're having the angle of inclination between two objects, know that it is also equivalent to your angle of depression, like that. So these are the information that you need to master this 2D as long as grade 10 is concerned. You just need to understand this that you talked about, that sin theta is equals to opposite over hypotenuse, tan theta is equals to opposite over adjacent, cos theta is equals to adjacent over hypotenuse. And also you need to understand that for you to find information in another triangle, when you are given maybe 2 or 3 triangles, you just have to use the triangle that is having more information and see the connection between the 2 triangles, and then you can pass the information from another triangle to another triangle, as well as you need to understand what is the angle of inclination, the angle of depression. Yeah, I think that's all. So I think we can just try to tackle the questions so that you see how it goes. Let's take a look at this situation that we're having. It says that a handman attempts to reach the roof of the hall with a ladder that is 5 meters. So we can see that this is 5 meters there in length. Unfortunately, the ladder is too short and a new ladder will be required. Suppose that the length of the ladder needed to reach the top is to be double the distance from the foot of the ladder to the wall, right? So we can see that this and this, the relationship is this line is twice this, so that's why it is represented by 2x there, and this is x. Also, the angle between the current ladder and the ground will need to be equal to the angle between the 2 ladders. So it means that here it will be theta and here it will be theta, right? So like I said, we can see that you're having 2 triangles and this is supposed to be 90 degrees because this is between the ground and the wall. So it always makes a 90 degrees, right? So we are having 3 triangles, but the ones with the right angle triangles, they are actually 2. So we see that we're having this, the one with 2x there. So this is our first triangle with a 90 degrees. Can you see that? And we are also having this small one that is passing through 5 meters with 90 degrees. So our larger triangle, we can see that it is having 2 theta as the angle because it is theta plus theta giving us 2 theta. So the first question says calculate the value of theta. So we need to know what is the value of theta. So let's use this bigger triangle, because you can see that there's a relationship between this one and this one, which is this one is 2x and this one is x, right? So which ratio that can help us to find the hypotenuse and the adjacent? So this is cos of theta, right? So let's see how we can solve that. So we know that cos of theta is equals to adjacent over the hypotenuse, right? So now, since we are having this whole angle like that, so it means that this is cos of 2 theta being equivalent to adjacent, which is x, over our hypotenuse, which is 2x. And already you can see that we're having x on top and x below, so it means that this can cancel each other out. So it means that our cos of 2 theta will be equivalent to 1 over 2. So now we can do the second function of cos. So this our 2 theta will be equivalent to cos the second function of half, right? Which you find it to be 60 degrees. But now, since we can see that here we are having 2 theta, but they said we must find the value of theta, so it means that we must divide by 2 there and divide by 2 there as well. So now our value of theta becomes 30 degrees, like that. It is very, very simple, right? And the second question says, hence or otherwise determine the length of the ladder should be to get the element to the roof. So we need the length of this. That is the length that you're trying to find. The second ladder that was put there, right? So what can we use? Here we can see that we're having a value. So let's try to use the small triangle to find the value of x. So if we can find the value of x, it means that we can multiply by 2 to get that, right? So again, which ratio should we use? We can see here that this is the hypotenuse again, and this is the adjacent. So we can use cos theta as well. So let's see how we can deal with this one. So again, we know that our cos of theta is equivalent to adjacent over the hypotenuse, right? And which our adjacent is x and the hypotenuse is 5 meters, right? But what is the value of our theta? This will be cos of 30 being equivalent, because so that the value of theta, it was 30 degrees from above. You can see that. So this is equivalent to x over 5 meters. So we can multiply both sides by 5 meters to get rid of 5 meters this side. So which means that our value of x now, it becomes 5 multiplied by cos 30, which gives us 4.33 meters. But now we need the value of 2x and not the value of x. So it means that our 2x will be equivalent to 2 multiplied by 4.33 meters, which our 2x will be equivalent to 8.66 meters. So it means that the length that is needed, it is 8.66 meters, just like that. And here we found our value of theta to be 30 degrees. As simple as that. Let's just move to another example so that you can see how we can solve it as well. Here we're having this example. It says that an aeroplane at J is flying directly over point D. So it is directly over it. So it means that it is 90 degrees here, is shown there. And then the height of 5 kilometers, at the height of 5 kilometers. So this is 5 kilometers away, right? It is heading to length at point K. So this is point K. The angle of depression from J to K is 8 degrees. So this angle of depression, like we said, what is the angle of depression? It is the angle connecting 2 points or 2 objects when you are viewing from above. So it is from the horizontal and the line that is connecting objects, just like that. S is a point along the road D to K. So we are also having the point S there. And now they're asking us what is the value of JKD, the angle of JKD. So this, from the previous thing that we have, from the diagram that I've showed you, you can see that this is the angle of what? Of inclination. So this is our angle of inclination. Angle of inclination. And you know something about the angle of inclination and depression, right? I said that the angle of inclination is equivalent to the angle of what? Of depression. So it means that also this is 8 degrees. So here our answer is 8 degrees, because our angle of inclination is equivalent to the angle of depression. Now they said calculate the distance dk, correct, to the nearest meter. But here we can see that we are working with kilometer, right? So we can try to change the kilometer into meter. So how do you change kilometer into meter? We multiply that by 1,000. So this gives us 5,000 meters. So always check how they want your answer as. So they said to the nearest meter, so let's change our units to meters instead of kilometers. So they said they wanted the distance dk. So dk is this distance from this point up to this point, right? But what do we know in this triangle? You can see that we're having this triangle, this big triangle. Let's try to show it there. I'm sorry about this drawing. So this is the triangle that we're having, triangle DK, right? So in this triangle, we can see that we're having the opposite, because this is our 90 degrees. So it means that this is our hypotenuse. This is our opposite. And this is our adjacent. So in this triangle, we are looking for the adjacent and we're having the opposite of this angle. So which ratio requires us to use opposite and adjacent? Yes, it is tan of theta. So 5.2.2, we can say that our tan of theta is equal to the opposite over the adjacent, right? So this is tan of how many degrees? 8 degrees will be equivalent to the opposite, which is 5,000 meters, over the adjacent, which is dk. So now it means that we can multiply by dk. So it means that dk multiplied by tan of 8 will be equivalent to 5,000 meters. And now we can divide by tan of 8, which means that our dk will be equivalent to 5,000 meters divided by tan of 8 degrees. Now we can find that our dk is equivalent to 35,576.8 meters. So this is 0.8 meters, which we can now round off to the nearest meters, which gives us 35,577 meters. So that is the length of dk. So this is 35,577 meters. So let's move on to the next question. If the distance SK is 8 kilometers. So now we know the distance of SK is 8 kilometers, right? So let's just represent that differently. So this SK is equivalent to 8 kilometers. Calculate the distance ds. So the distance ds. But you can see already that SK is 8 kilometers, but the whole of DK it is this much. So let's change it to kilometers. We can divide it by 1,000, which we can get 35,577 kilometers. So this is the distance, the whole distance from D to K is equivalent to that. So if we need ds now, and we know that this is 8 kilometers, so it means that we can subtract this all and we subtract 8, right? So it means that our ds, so this is 5.2.3. So our ds will be equivalent to 35,577 kilometers minus 8 kilometers, which we can find it to be 27.577 kilometers, as simple as that. So the last question now says, calculate the angle of elevation from point S to J. You remember what is the angle of elevation, right? Yes, so let's see from S to J. So our point S, this is our point S, and this is our point J. So we know that the angle of elevation is between the horizontal and the line connecting the 2 points or the 2 objects. So this is the angle that we're trying to find. This is the angle of elevation. So this is our angle of elevation, right? So how do you calculate this angle of elevation? So we can see that we're having a new triangle here, JSD. Can you see this triangle? And you know a lot about this triangle. We know that this is 5 kilometers, and we know that this is, we just calculated that as 27,577 kilometers. So again, this is the adjacent and this is the opposite, right? So we can find the angle, and which ratio can you use? That is the adjacent and the opposite. Yes, it is tan of theta. So let's just use that to find the angle of elevation. So it means that now our 5.2.4, now we can still use our tan of theta being equivalent to the opposite over the adjacent, right? So our tan of theta will be equivalent to the opposite, which is 5 kilometers, over our adjacent, which is 27,577 kilometers, right? So now it means that we can do the second function of tan. So it means that our theta becomes of 5 over 27,577, and we can find that our theta is equivalent to 10.27 degrees. But the question says correct to 1 decimal place. So it means that we must make this to 1 decimal place. So it means that our theta will be equivalent to 10.3 degrees. As simple as that. So it means that now we can move. I think we can do one last question, and I think you'll be perfect on working with this. So let's move to the last question. So here we're having 2 buildings are 45 meters apart. So already we know the distance between the two buildings, it is 45 meters apart, separated by a park. A person on top of the shorter building, so we are having a person that is standing there at point A, calculates the angle of elevation from of B from A to B 30. So this is our 30 degrees, yes. And the angle of depression of D, the base, okay, there is the base there, is to be 50. So this is the angle of depression, that is 50 degrees. So this angle is going down 50 degrees, right? And now let's take a look at our questions. So the first question says, determine the size of ADE. So always remember that what I said that if you're having a situation when we are having two objects that are connected like that, A and D, if our angle of depression is 50, it also means that our angle of inclination is also 50 degrees. So it means that this should not trouble us to find the angle ADE, as our angle AD is also equivalent to 50 degrees. So now they said calculate the length of BD. So we need the length BD, the height of the taller building. So let's take a look at our building. So this building is connected by something that is simple to notice. So this BD, it is connected by this line that is in this triangle, the smaller triangle. We can see that we're having this line, and also in this triangle we can see that we are having this line C. We're having line CD as well, that is in the bigger triangle. So it means that if we can find the length of this line in the smaller triangle, and we can find the line of this in the bigger triangle, it means that. So now, how can we deal with this BD of ours? So first, let's calculate BC in this smaller triangle. So already we know that the distance between these two, it is 45 meters. So in this, we're having this angle here as theta. So this will be our opposite, and this will be our adjacent, right? So what is the connection between the opposite and the adjacent? We know that we can use tan of theta, right? Am I correct? Yes. So let's use that. So we can use our tan of theta being equivalent to opposite, which is BC, over our adjacent, which is AC. So our tan of 30 degrees will be equivalent to BC over our AC, which is 45 meters. So now we can multiply both sides by 45 to get rid of 45. So multiply by 45, multiply by 45. So this means that our BC can now be equivalent to 45 multiplied by tan of 30, which our BC will be equivalent to 25.98 meters, like that. So this is our BC to be 25.98 meters. So now let's try to find the line CD. So if you can find line CD, we can add these two to find the length BD. So now let's go to, again, we can see that this is our angle there. So this is our opposite, and this is our adjacent as well, so we can use tan theta as well. So tan of theta will be equivalent to our opposite, which is CD, over our adjacent, which is AC. So this is tan of 50 being equivalent to CD over AC, which is 45 meters as well. So now we can multiply both sides by 45, multiply by 45 to get rid of that. So our CD becomes 45 multiplied by tan of 50, which our CD becomes 53.63 meters, like that. So this is our length, 53.63 meters. So now to find the overall length, which is BD. Our BD will be equivalent to our BC plus our CD. So this will be 25.98 plus 53.63, and which will give us 79.61 meters. As simple as that. That's really wonderful. So now let me just leave you with something to try on your own, so that you see your progress, right? And I'll be posting more of this as time goes on. So if you've enjoyed, if you've gained something, please show that by subscribing to our channel, liking, and also commenting what you think. This will keep us more dedicated to make videos for you. Other than that, I will see you on the next one. Have a lovely day. So you can be trying this on your own time. Just take a screenshot, and then you can study this on your own and try to calculate the unknowns. Have a lovely day. Please don't forget to subscribe.